Hi, good afternoon. I'm Bruna, and I'll be talking with Case about the technical details on DCAT AP and FAIR Datapoints. Looking at the overview, we are now talking from cluster 3. So, to start, I would like to declare our vision. As a community, we would like to have a smart infrastructure for research and innovation where users easily find and reuse resources that are relevant for them. This vision requires that resources are described according to some international standards, so that their metadata is rich enough and interoperable. One important international standard is DCAT, which is being used by the European Health Data Space and also further specified for health-specific information. And we also have DCAT AP, which stands for Application for Portals, that we're going to go into details in a little bit. So apart from these international standards, so that we can be interoperable, the resources in this infrastructure also should provide semantic enriched metadata. Why is that? Because then the information about your resource is unambiguous for both humans and computers, and the computers can take some actions for us and automate some of these tasks on finding resources that are relevant and also make sure that our resources are findable by others. So let's talk about metadata. Have you seen this icon before? Do you know what it means? Right, it's indicating battery level. And you know where this icon can be found? Well, probably most of your electronic devices, right? What about this icon? Well, in some of your electronic devices that take photographs. What about this icon? Well, this is, as you can imagine, a specification of photographs, right? In the left, you can find this icon when you are pressing the automatic mode in your lens interchangeable camera. And on the right, you will see also in your smartphone this icon when you want to take a panorama picture. And it's the same for research data. All datasets have, for example, titles and descriptions. Some datasets with title and description share some properties in a specific domain. And sometimes that domain has a subdomain that will have even more specific properties. For example, here on the left, you see, let's say genomics may have something with proteomics and other types of omics metadata. Right, here at Health.AI, we are trying to identify the first layer at the moment for Plateau 1. So what is the core metadata schema that all resources relevant in our community have in common? So Health.AI wants to supply this generic schema for users to increase the findability of their resource of interest, for example, datasets. And this core metadata schema is based on international standards, as I mentioned as an example, the DCAT and DCAT AP. And also it will include in the future domain metadata requirements, for example, for omics data. So how do you understand, how do you read metadata schemas? So a metadata schema has a few elements, but you will always find classes. Let's say dataset is a class in a metadata schema, and these classes have properties. For example, a dataset has a title, and these properties should point to an instance. For example, the title of this dataset is the human genome dataset. As if you take a person is a class, a person's name is a property of that person, and in my case, the value or the instance would be Bruna. So this is DCAT at first glance. Don't try to read it. You can access the link in the bottom and explore on your own. But this is an overview. Each of these big boxes are classes, and then you see a list of the properties of each class. So the main classes in the case of DCAT are catalog, here on the left, dataset in the middle, and distribution. DCAT sometimes gets updated as everything evolves in our field as well. So for instance, from previous DCAT versions to the new DCAT version, they added a new class called data service, and they also added some relationships and also the possibility of having a catalog record connected to a catalog. So when you look in depth into one class of DCAT, you always find in the bottom the properties that are inherited by a superclass of this class in the example. So here we can read that dataset is inheriting from resource quite a few properties. And on the top, you'll see the properties that are exclusively from this class. Right, now that you know a little bit about the structure of DCAT, I would like to present the structure of DCAT AP portal. You will find the same main classes like catalog, dataset, and distribution, but also a few other important properties, some specifications on cardinalities, and what properties are mandatory or optional for the case of portals in Europe. So DCAT AP portal is an extension of DCAT and is also defining these mandatory fields for European portals. For example, for the class dataset, you see that the only mandatory fields or properties would be description and title, and the rest of them are completely optional. This type of decisions we can also take into account when we are defining our own profile for DCAT in our community or in our research infrastructure in the Netherlands. So in comparison, you see that DCAT AP will have information about a property being mandatory or optional. You'll see the cardinality. Is it like one value that you're expecting for that property, or is like 0 until the infinite? It borrows properties from other schemas like DCAT and borrow classes from DCAT and is specific for data portals. Well, and then DCAT is something more general. It does not give you any constraints about how many values you should have per property and which properties are mandatory or optional. Now I will hand it over after presenting the basics of metadata and DCAT AP to Case, where he will present the FAIR data point and how this DCAT is related to FAIR data point. Thank you.
Okay, so we'll continue with the FAIR data point. Before we do the why, maybe first what. The FAIR data point is a lightweight service protocol acting as a metadata provider service. So building on top of the model that Bruna explained, we add a layer of organizational metadata where a consumer of the metadata can find out who is running this FAIR data point. And it combines existing standards, so having the metadata available in an RDF format, having the DCAT model describing the metadata, and having navigational metadata through the linked data platform specification. We have a reference implementation available that demonstrates the behavior of a FAIR data point. It's a free and open source tool that allows you to run your own FAIR data point. For more information, there are a couple of pages you can visit. We have the landing page of fairdatapoint.org, where some brief information and some example implementations are listed. We have the home.fairdatapoint.org, which is an index of existing FAIR data points that ping to that index, and there is a specification for the behavior of the FAIR data point. Then the connection to the national infrastructure. In this sketch, we describe the sources exposing their data through metadata in a FAIR data point, whether local, as close to the institute as possible, or a central one that doesn't matter for this example. In the middle, you can see a harvester that harvests the metadata in the FAIR data points that are available. That data is then published in the data catalog or cached in the data catalog, and that data catalog is then available through the search and request portal. So in summary, we need your metadata to facilitate finding the resources. We do it in this way through the FTP because we have a standardized approach for the metadata. We're reusing interoperable standards. Whereas if we wouldn't do that, then connecting new sources would require reinventing the wheel for every source. So then what's next? In the coming months, we'll continue to improve the documentation on the onboarding procedures. It's available on the Confluence wiki, and there you can find descriptions of how to model your metadata and how to publish your metadata on a FAIR data point. And that's it. Thank you very much.